All right, week 12, and we're going to be talking about Extrema today. So we're going to first start off with a little bit of a review from Calc 1 of this idea of Extrema, because this has been a couple of years since we maybe seen this. And so we use the language of local min and local max to talk about extreme values, and we're going to focus on locals, and then remember there are absolute mins and maxes as well. And we talk about a function having a local max at a certain point if at that point we have the function value at a being greater than or actually equal to f of x for any other x, and I'll say for any x near a. Okay, so the idea here is that if we have some scale, okay, and we have a function, okay, something like that, let's say, and we're looking at, we're thinking that this is a maximum. Let me do that in red. Then this would be our a, and then this as a point would be a comma f of a, and we're thinking that in a small region near that point, that it is the highest y value. Okay. We also have done Calc 2, right? So we might be able to say this symbolically. We could say that there exists a value r such that when the distance between x and a is less than that distance r, that implies that f of a is bigger than or equal to f of x for all x. Okay, so we can do that. Mins are defined in the exact same way. It's just instead of f of a being bigger, f of a is now smaller than x for all x near a. Okay, and so that's our standard parabola that opens up type idea. Okay, so we're thinking that if this is our value that we suspect is a min, so here's a, and then we can again find that point as a comma f of a, that we would see that again there exists an r such that when x minus a, that's a absolute value, is less than r, that forces f of a, f of a to be less than or equal to f of x. That's an x. Okay. So then the next question is, okay, well, how do we find that x is equal to a, or where these local mins or maxes occur? Okay, and so maybe you remember some definitions, maybe not, but we call those points critical points. Okay, and so we talk about critical points as where the derivative is 0 or where the derivative is undefined. And so then with these, we might remember we have these old tools, first and second derivative tests, and I'm just going to make a little chart here that kind of summarizes that whole thing. And so what we would say is, well, if we had a point in mind, say like x is equal to a, and we think that's our critical point. Okay, so critical point, and I'm just going to put this in a bubble as an idea. Okay, what I would do, and honestly the second derivative test is nicer if we're able to compute the second derivative quickly, but we would have a local max if the second derivative at our value that we suspect is a critical point is less than 0. Okay, and a local min if the second derivative is greater than 0. And then really if the second derivative is either 0 or undefined, and I'm just going to do UND for undefined, we don't have any information. We talk about the second derivative being 0 as a possible point of inflection. You might remember that language where it changes concavity, and also remember that this is the same as concave down, and this is concave up. So just remember that. With the first derivative test, that's where we actually ended up making those charts where we had like f and f prime, and here was a, and what we would see is that the derivative for a maximum would go from being, positive on the left side of a to going negative on the right side. And what the function would then do is be increasing and switch to decreasing, and there we can actually see that maximum occur. Similarly for the min, what we would see is on that little sign chart of f prime and f, we would have minus and plus, and then that would go from decreasing to increasing, hence seeing the min. And no information, it would just be something occurring. We could do f prime and f, and we have a on there, and we might see excuse me, either both of the signs being positive or both signs being negative, and that's just going to mean that it's going to either continue increasing on both sides, continue decreasing, and this is when we typically got like a saddle going on. Okay, so we wouldn't discuss any local extreme values at those points. Okay, so that's going to just kind of wrap up our review from Calc 1, and now in the next video we're going to discuss what this means in the case of multiple variables.